whether we can trust the IoT devices that we use. But I don't know how many of you, I haven't met all of you yet, but to give you a quick sense of my background, I started in mobile communications several decades ago, went to voice over IP, and then actually created something pioneering called a session border controller. So that's a piece of security. Essentially, it's a voice over IP firewall. So I've been dealing with security since those days. And then from an IoT perspective, worked for a smart grid startup that worked on a very critical piece of equipment, IoT equipment, that enabled solar integration with the regular grid. So that was very instrumental in making that happen. Then worked for an IoT service provider where we did a number of different things. One of them was called electronic monitoring, which is, to put it simply, just an ankle bracelet. And the security there is also interesting because it's not only external actors, but also the person who's wearing it who wants to actually do something to break through the security so they can, tamper and make changes to that. And then I also worked for a SIM card company providing the IoT security layer on top of SIM cards. So my IoT experience has been extensive, and it's all touched upon security. And one of the things we've learned over the years is that securing devices or IoT devices is very, very hard. So that's the background I bring here. That's what I want to talk to you all about. So currently, I'm the CTO of Somos. So for those of you who don't know about Somos, Somos is simply put, a carrier behind the carriers. So we administer the North American numbering plan, which means we issue the phone numbers that are used by all of us, whether it's on our phone, on our tablets, on IoT devices, whatever the use case may be, it's all issued by us. And we do it for the +1 country code, so it's not just the US, so it's US, Canada, and 20 other Caribbean countries. So we also administer something called the toll-free number database, which is, again, all the toll-free numbers. There's about 45 million of them in active use right now that are being used across the +1 country code. And also, importantly, there's another one called the reassigned numbers database, which is an essential database for TCPA compliance. So all these things are actually administered by us, and as part of what we do the lifecycle management of these identities, and we have 7 billion of them that we have to track the lifecycle of. And what we find from actually doing that is we can create number intelligence services which can expose fraud. So we actually have solutions that make a very small dent in the big robocall problem that we all face. And similarly, because we're agnostic to the use case, the same thing can be applied to IoT. So we do fraud for telephony, security, and IoT. And talking about security and IoT, this morning, we launched our solution called Somos ID. So this is the press release that just came out this morning. So let's get to our topic, IoT devices. I'd hate to talk about the pandemic now, but whatever it did, it definitely accelerated digital transformation. It's been 4 years since then, but the transformation has not slowed down in any way, right? So there's been tremendous IoT use cases and deployments driven by remote work, driven by enterprises needing the ability to manage IT, essentially extending the IT perimeter into somebody's home where there are intersections with somebody else who's also working in the same household, and so on. So the complexity has only increased. And what this means is that there was a lot of urgency for these deployments. There was a lot of speed that was put into this, and also created very increased fragmentation when you do things in a hurry. So as a result, we magnified the problems along with it. So the latest report from Nokia says that just in the last 2 years alone, the number of IoT devices that were involved in DDoS attacks went from 200,000 2 years ago to 1 million devices last year. So this is incredible. And when you look at other aspects of it, there are bugs, there are vulnerabilities that are existing inside IoT devices, whether they are in industrial, whether they are surveillance like cameras, or even in medical devices. And the worst thing is, even our smart home devices, such as the Belkin smart plug, also has vulnerabilities. So we just can't seem to get away from this. And I talked about the smart grid before. Let's talk about critical infrastructure. This is an area where we have the really weak links. So the SCADA networks that run our electric utilities, our water utilities, and so on, are actually very, very easily susceptible to attacks. And the worst possible thing here is that you have nation states actually becoming the bad actors here. So Iran, China, Russian hackers routinely want to probe and test our critical infrastructure networks to see if they can breach that. And even though there are existing patches, when I say patch, I mean if there are known vulnerabilities, there are ways to actually mitigate them. Still, the application of the patch to make that vulnerability go away is still an operational exercise, right? And that takes a while to happen. You have to validate the firmware. You have to, run a campaign to actually update all the devices that are probably remote. There are truck roll issues if it has to be touched. So the complexity of those means that we have vulnerabilities that exist in the network for a long time. So I'll talk about this particular Citrix one. So NetScaler, so the Citrix NetScaler is a gateway device that's fairly popular. It's widely deployed. And in August of last year, the CVE stands for Common Vulnerabilities and Exposure, was listed, actually came out that said that the Citrix NetScaler had a particular vulnerability in August. Citrix issued an update in October, it's 2 months later, right? And in that time, in those 2 months, the actual exploit to take over, to actually breach all those Citrix NetScaler devices was actually being published and sold on the dark web. So think about this. So August, it was identified. October, they officially released a patch for it. And those 2 months, the exploit was actually widely known. So this causes a big issue because it's not only the operational part, just the delay in putting out a patch creates so many issues. Let's go into the CVE part a little bit. So CVEs, the common vulnerabilities and exposures. So these are created by white hat hackers, security professionals, sometimes software developers who are working on open source, who create these CVEs and actually publish them on public domain websites and so on. So there are a lot of databases available today which list out the CVEs. And that's a very important resource that's available for security professionals to actually say, hey, I know that there are these vulnerabilities and potential exploits. Here's what I can do to actually fix those things. I want to draw your attention to one particular one, which is this log4j issue. So log4j was one of those vulnerabilities that was exploited since 2015 onwards. It was an end-of-life piece of software that had this issue, and the funny thing is, in 2023, there are still 32% of applications that still have that end-of-life version of software in them. So this is just waiting to be exploited. The second thing I want to point out is that from a fixed network access perspective, 8% of them are IoT devices, but they are responsible for 40% of all DDoS traffic. DDoS is distributed denial of service. So even though we think that IoT devices cannot be compromised, them being compromised is one aspect of it, but them participating in a DDoS attack as part of an extended botnet framework is really actually the second part of the problem. And today, 60% of attacks in the telecom networks are linked to IoT devices, essentially extending their botnet fabric across. So how is this happening? So one of the things we looked at is the open source software vulnerabilities. So if we take open source as, it's a great public good in the sense there are all these smart people who are creating open source software, contributing so that it definitely accelerates time to market for applications, time to market for devices, makes sure that there is not just a small team of software developers, but a wider community who can help support and build new software and so on. But this is from the Eclipse Foundation, and they say that 97% of a typical Java application is made up of open source libraries. So clearly there is, this allows for great reuse, but it also means that it's easy to inject vulnerabilities because open source is such a common part of most applications. And even in the actual application, the Eclipse Foundation says that 76% have some kind of flaw, but a quarter of them, 25%, have something that's actually very critical. So if you look at the universe of software that's actually being built into IoT devices and all that, if 25% of them have a critical flaw, so we talked earlier this morning about the 10x deployment that's been happening. So you can see how extensive the actual software vulnerabilities are going to be across these IoT devices. So we've gone from critical infrastructure, patching, CVEs, software, vulnerabilities, and all that. What does it mean? Why do we really need to care about an IoT device and those things? So let's talk about what makes up an IoT device. If you take any use case, whether it's smart grid, industrial, health, transportation, whatever, if you take an IoT device, at the highest level, it's got three layers or three things to it. There is the hardware, which is the compute, connectivity, the sensors that need to be there for it to work, and the software that actually makes it work, and ultimately the identities, the configuration, and the metadata that actually make it really useful. That's the one that's actually making it useful within our enterprise applications. So how do we qualify what these things are? So if you look at the attributes with respect to each of those, if we say hardware, we need to know what is in the hardware. So the hardware bill of materials is a very common concept. Hardware engineers, manufacturers, they all know that what comes in the hardware can be listed out as a hardware bill of materials. the firmware of the software has been something that's opaque, right? So I'll date myself. At one point in time, I'd turn on my PC and there'd be ms-dos.exe, right? So that was one executable, completely opaque, binary image that would run and make the operating system happen so you can run your applications on top. It's the same concept that's there even today in software. So you think of it as a binary blob that's just running on the hardware to do the magic that you want, right? But the increased need for knowing what is inside, is driving people to come up with something called a software bill of materials. Is to say, okay, now break open the software and lay it open so that you can see what the contents, the various libraries, the various open source components that are part of that, so that we can test it against the known vulnerabilities. The last one is around identities and configuration. So identities is a very interesting problem when it comes to IoT devices. So you take a typical IoT device, there are minimally at least 4 identities, probably more. At the base level, the manufacturer is going to put a physical identity, a serial number, a VIN, or something like that. At the next layer up, because every IoT device is actually a connected device, you got to have a network identity. Otherwise, it's not going to work. So there's a MAC address, an IMEI, a Bluetooth ID, and so on. This is the identity that's actually presented to the network. The third level is where a service provider can actually provide service to that device. That's what we call the service identity, which is, in the case of cellular, everybody understands an IMSI or an ICC ID and so on. These are the things that are stamped on the SIM card, and the SIM card is essentially providing that identity. And when you look at the enterprise, they don't care about the serial number or what the MAC address is and so on. They really care about the fact that it needs to be an ID that can be used by people in the enterprise and by the business processes that the enterprise actually uses. So we call that the meta identity, right? And that's the real thing. And interestingly, they all have their own life cycles. So you can replace a device, the physical identity changes, and the actual network identity may change. But as an enterprise, it's still the same tracker that's on your Ford F-150, right? You're not going to change the meta identity. And similarly, you swap out a SIM card, so your IMSI and ICC ID changes, but it's still the same device to you because it's providing the same function within your enterprise. So each of these identities has its own life cycle. And what that does is it creates a lot of fragmentation. So knowing about all these things, so we talked about the software issues, we talked about devices and what it's composed of. Where is the trust gap? The trust gap, there are many elements here. The first one is you can have an IoT device that can last a few months, a year, or in the case of industrial and smart grid, that lasts 15 plus years. So the first one is how do you provide a consistent security posture for IoT device over their entire lifespan? Especially with a threat landscape that's changing by every minute. How do you make sure that you have a consistent security posture? The second one is how do you make sure that if there are security updates, how do you make sure you capture it in the firmware and make sure that the firmware gets updated? The irregular firmware updates is another issue, another problem that creates this trust gap. The third one is warranty and technology obsolescence. So most manufacturers hate to give more than a year's warranty on it. They may try to get you on an extended warranty if possible, but that's about it. If you have a a device that's going to last 15 years and your warranty is 1 year, how are you going to maintain it over the course of the other 14 years? How are you going to make sure you get the appropriate maintenance for it? And the crazy thing is technology changes. I had this interesting experience a few days ago. I was searching around for some old files, and then I realized I had it on a disk drive from maybe a decade ago. And then I looked at it, and it required the BlackBerry USB connector. And I was like, dang, who has that anymore? I don't have it anymore. So here is, technology that changed, and it left me high and dry, even though I had the old drive with the files in it, but I could never get access to it. So technology changes. How do you make sure that we can keep up with it? This enhances the trust gap. The last one, just as we talked about the identities, having multiple identities, especially across varied administrative partners, creates even more of a trust gap. So if you look at a communication service provider, right, like an MVNO that's providing a SIM card, they don't care about the device. They just give you a SIM card and they manage everything through that SIM card and the data plan. They just look at it as, okay, here's an ICC ID I gave you, I'm just managing ICC IDs. And the manufacturer provided the radio module or the Mac card or the cellular module, only looked at it as, okay, I provided this module with a particular IMEI. I don't know about anything else. So there are all these different identities there that have different administrative control on it. This creates further breakage of trust. But all of this has a major cost. So this is the company Ponemon that did the research on this. So they surveyed a whole bunch of CIOs who said that 90% of them are concerned that their devices are not sufficiently secured. And they estimate the cost of a breach to be $9.48 million. And it's only going up. It was 9.44 before, and 1 year went to 9.48. So what is happening to the industry? What are the reactions to what is happening? The first thing is we've seen an increased number of regulations that have started to come out. So in the US, FCC, FTC, and NIST are really looking at how to secure devices. UK has already passed one, and EU has already passed the Cyber Resiliency Act. Then the macro trend is that CFOs probably know this. The cybersecurity insurance that they're paying actually has gone up, the actual insurance premiums. So the cybersecurity insurance market as a whole has a CAGR of 26%. So it's a rapidly growing market because they realize there are a lot of security breaches, and they're paying more in damages, but they're also collecting a lot more in insurance premiums. Shadow IT becomes the CIO, CISO's biggest worry. So what is shadow IT? As I was telling you before, we all work from home, or most of us will probably work from home, or have the flexibility to be hybrid. So the place of work is no longer defined by a perimeter anymore. It's kind of a blurry edge. And at the same time, you have the company has given us IT assets that we use at home or wherever we work. And what happens is that there is probably a partner who's also working at home, kids doing homework. All those things are essentially blurring the line between what is one enterprise's IT boundary overlapping with some other devices that could potentially inject vulnerabilities into that network. So this is the shadow IT problem, as they call it, and there's no obvious solution yet, but what has happened is that CISOs have started putting out policies that try to address this. So one of increasing concern. The last one is all the guidelines and standards on visibility and traceability. So if you look at the NIST standard for cybersecurity, the first thing that they talk about is identification. And what do they mean by identification? It means you need to know, you need to have the visibility and the traceability of the thing that you're trying to secure. So IT managers have a great name for this, great phrase for this. They say you cannot secure what you cannot see. And what do they mean by see? It just means that the IoT device has a complex makeup, and it's not just the fact that it's a device with a known whatever, IP address or whatever, but it's really about its complex makeup, which includes the hardware, the firmware, the various identities and the configuration, and the overall security posture. This is what they're talking about. And you can see that the push for visibility, traceability, and serviceability has been really increasing over the last few years. So this is a once in our lifetime thing where Congress passes a $1 trillion bill, right? So in the $1.2 trillion infrastructure bill, they talk about modern, connected infrastructure. So it's as vague as possible, and there are a lot of people trying to define it. NIST is definitely defining it. And so this is a definite impetus for actually figuring out what modern connected infrastructure is. Second is the UK actually passed a regulation on firmware updates, which was a shot across the bow for all the serviceability aspects, right? So if they say, okay, if you're going to issue a firmware or software, it needs to have a certain lifetime so that you can actually make sure that there are updates to that. Then the NIST has been, NIST is National Institute of Standards and Technology. Sorry, I've been using without explaining what the acronym stands for. NIST is National Institute of Standards and Technology in the US, and they've created the standards on visibility and traceability, and this has led to what is known as the Software Bill of Materials standard. So there's now a format by which you can actually show what is in software through a Software Bill of Materials. Same thing for hardware, and these are now machine readable, exchangeable, and all of that stuff. And the FCC kicked off a notice of public rulemaking recently on what is called the cyber labeling program. So we all know about when we buy processed food, there's a nutrition label that we can refer to say, okay, hey, we know what the ingredients inside of this thing I'm going to eat are. It's the same kind of concept, but applied to connected devices. So you can actually say, based on the cyber labeling, what kind of hardware, software is in it, and just to allow you, just to promote trust in that device. The last one is the EU Cyber Resilience Regulation. This is extended the thing. It wasn't just IoT. It says any device, anything with a digital element. So which pretty much includes pretty much everything modern that we make. So this is a very expansive regulation that came out of the EU, which is going to probably be mirrored everywhere else too. But one of the key things that comes out of this is that we have now standards for software and hardware bill of materials. There is increased visibility into knowing what the software and hardware bill of materials are, vulnerability tracking, and identifying affected devices. So it's not just tracking vulnerabilities, but to know that, hey, if there is a vulnerability, I can go back to say, okay, these 10,000 devices I know had this software in them, so I need to go fix those 10,000 devices. And the third thing, which is also becoming more and more important, is the need for updates to patch the vulnerabilities. So at Somos, we've been thinking about this hard, and we've been trying to put together, we understand that this is a huge problem. It's an issue of scale. It's an issue of companies requiring tools to actually do this in a more consistent manner. And what we've come up with is our solution called Somos ID. And Somos ID provides a comprehensive IoT device security risk and compliance monitoring. So it's all about providing the visibility and just on these 4 questions. The firmware status. Is the firmware current? Does it need an update? Do we know the bill of materials? Are there known vulnerabilities? And what components have known risks? And then tracking against vulnerabilities. So have there been exploits already reported on that? What are we doing about it? And lastly, keeping track of the device provenance. So device provenance is about IDs, credentials, and is the device even certified to operate? We've come across devices that have been certified to operate on Wi-Fi, but somehow also operate on cellular. So these are things that need to be looked at and fixed. So in a single comprehensive dashboard, we want to provide this so that you can, enterprise IT managers have a view into the security posture of their IoT deployments. So overall, the way Somos looks at it is we are a trust player. Being a carrier behind the carriers, we've had to service all the carriers. So we come at it from a very neutral perspective. And we manage lots of identities. And as part of this, we do the lifecycle management of those identities, including the IoT device identities. And we can expose cybersecurity risks posed by software, hardware elements, and other data, and then make sure that the data that we get out of this is the right data that we can use for compliance. So thank you all for your attention. We have a booth 919. We're doing a demo of Somos ID, which we launched this morning. So I would encourage you all to come and take a look at it and provide your feedback on that. Thank you again.